Okay. Good evening, everyone, and welcome to the 10th live session for the course Basic Real Analysis. So, today, what we'll be discussing is based on integration on multivariable. So, basically, we'll be dealing with problems integration on R2 and R3. So, to begin with, let's start with this first problem. Okay. So, it says that suppose you have been given a rectangle R. Okay, so this is a rectangle with corners. These are the corners 1 1 1 3 2 1 2 3. Okay, and this is the function that you have been given, just x square, and then you have to evaluate these two integrals. Since this is r x f x y dxy, and this y f x y d of xy. Okay, so this is very elementary problem. So would you like to try this? Meanwhile, maybe I'll draw some pictures. Because I'll wait for you guys. Okay, so you better try to solve this problem. This is 1 1 1 3 2 1 2 3. Okay, so how will you solve this? So over
Taking it parallel to x-axis or y-axis.
Yeah, okay, so let's start with the x-axis only. So this is how we can think of. So x is varying from 1 to 2, and sorry, so when I'm saying this, I should look after y. So y is varying from 1 to 3, and x is varying from 1 to 2. Okay, so it's the same thing. So these are the constants. So this integral, so let me go with the first one. So this x f x y dxy is equal to, so 1 to 2 and then 1 to 3. So this is x times, so this is x cube, and then you have dy dx, right? So dy will give you 3, and this will give you x4 by 4, 1 to 2, 3 into 4 minus 1 by 4, right? So this is the value. And for the second one, similarly, this is y times x square d of xy. This is equal to 1 to 2, 1 to 3, and then you have x square y dy dx. So this is x cube by 3, 1 to 2, and then y square by 2, 1 to 3. Okay, so this is what you get. Okay. So let's move to the second problem. So the second problem is, to you have to find the area of this region, which is a triangle. Okay, so let me describe what it is. Okay, so let me say this is triangle with vertices 0 0 a b and c d. Okay, where these are the constraint on a and b. So a is less than c and d is less than b. Okay, so this is the rectangle, so you have to find the area of the region. Okay, so what does this mean? So area basically means that you have to integrate this 1 on this whole region, right? This is what this means. Correct? So now
Yes.
so for that, now we'll have to see like how this R looks. Okay, so let's try to draw a picture for this R. Okay, so let me draw it here. So it's clearly in the first quadrant, right? So this is, let's say, X, this is Y. So the first point is this 0 0. The second point is AB. Okay, so we can see both B and A both are positive. So let's say it's lies somewhere here. So this is AB, and then C is greater than A. So let's see. Okay, so this is A, this is C, and it says that D is less than B. So suppose, okay, B I have drawn it here. So sorry. So maybe let me put it a bit in upward direction. So this is here, you have B and D has to be less than B. So let's say D is somewhere here. So this is CD. So the triangle looks like this. Okay. Okay, so this is how it goes. So now, how should we solve this? Can you tell me? What should be the first step?
Sir, first find out this equation of the lines.
Okay, yeah. Okay, so let's try to find out the equation first. Okay, so what is this equation? This is 0 0.
Y
So y equals to
T upon
d by c into x, right?
X.
So this is the first line. Similarly, this is, sorry,
Y is equal to B by A X.
y equals to b by a x. Okay, so let me see. Yeah. Okay, so this is the second line. And what about the third one? So here
So
I
Y
can,
minus
yeah.
Y minus B is equal to
Okay, y minus b equals to.
D minus B
Okay, so let me
upon
write
C
here
minus.
only. Okay, so y minus b, and then you are saying d minus b, and here it
No,
will be x minus a
yes.
upon c minus a. Okay, so these are the lines that we get. Now how should we integrate it?
So take line parallel to sir Y axis, sir.
Okay,
We
so at
have to
this point.
divide this region in two parts.
Okay, so this is how you will divide it, right?
Yes.
And now,
So now take strip parallel to Y axis.
so you are saying like this,
Yes, sir.
right? In this region as well. So the
Hmm.
first thing is that we are dividing this x into two parts, the interval AC, I mean 0 to C, right?
Yes.
So what you are saying is basically that we'll first okay, so we'll first split this. So let's look at just from 0 to A. Okay, so this is where x is varying from 0 to A, and in this region y is varying from, as you mentioned, that d by cx to this b by ax, right? So this is one. So first dy and then dx. For the second one, we are saying from A to C, and then y is varying from, again, from d by cx to, okay, so we'll have to simplify it a bit. So this can be written as y equals b plus
B plus
d minus b
B by
upon
B minus B by
c
C minus.
minus a into x minus a. So okay, so whatever it is, so let me just keep it blank, or let me write it small. B plus d minus b upon c minus a into x minus a. Okay, again integration with respect to y and then with respect to x. Okay, so now, so this is how we can write this, correct? Now there could be other possibilities that you,
Yes,
as
sir.
you
You
said,
can take line parallel to the X
x
axis.
axis. So here we can do it in both the ways, right? So this would be the line, and in that case we can correspondingly, the first will have to integrate with respect to x, correct, where x will vary from this line to this line, and y will vary from 0 to b, correct? I mean 0 to d and then d to b. This is how it will go. Okay, so anyway, so let's try to evaluate it. So this is 0 to a, this would be b by a minus d by c times x, am I right? Yeah. And then dx, and over here you get a to c, and then you have a bit complicated but still it would be the same, b plus d minus b upon c minus a, x minus a minus d by cx dx. Okay, now this is b by a minus d by c, a square by 2. Okay, and here what do I have? So here it is b plus, so this is just b times c minus a. Over here I have plus d minus b c minus a, x square by 2 will give me c square minus a square by 2, and again minus d minus b c minus a into a times c minus a minus d by c, c square minus a square by 2. Okay, so when you will simplify it, I think it should reduce to some simpler thing. Okay, so I'm leaving it to you, so now you can simplify it further. Okay, let's move to the next problem. So up next we have this. So you have been given this function, so find the volume below the plane z equals x minus 2y and above the triangle T formed by x axis, y axis and x plus y equals 1. Okay, so here it's like the, so suppose you can treat this as a function. Maybe let me, so first let us see what is this triangle. Okay, so this triangle is simply this. Suppose this is x, this is y. Suppose this is x plus y equals y, x plus y equals 1. Okay, so it's kind of like the question is saying that suppose this is the domain of some function, and the function is basically this, f of xy is nothing but x minus 2y. So when you are plotting it on the z axis on the vertical line, so you'll get some structure, right? So so it's something in the above, like above this triangle there is something, and then you have to calculate the volume. So basically the volume between these two, z equals to 0 and at that level whatever comes in between. Okay, so now to do this basically you have to again like understand the domain, that's all and nothing else. So in you will put this function, so what we have to do it here, so to find the volume it's like you have to integrate in this triangle T. Okay, and this x minus 2y d of xy. Okay, that's all you have to do. So again the main thing would be to write this domain, that's all. So then you can rewrite this as iterated integral, so it's like x minus 2y, and now you can clearly see that your x, okay, so if you let's look at this horizontally, so now your y is varying from 0 to 1, so this is 0 comma 1 and this is 1 comma 0. Okay, so your y is varying from 0 to 1 and your x is varying from 0 to 1 minus y, right? And then you, so dx and then dy. Okay, I hope I've done it correctly. Okay, so now you just integrate, that's all. So this is x square by 2 minus 2yx 0 to 1 minus y dy, and then you just, so you have 0 to 1, this is 1 by 2, and then you have 1 minus y square minus, and then 0 minus 2, 0 to 1 y times 1 minus y. Okay, I think it can be clubbed together, or let it be. I think it should be clubbed. Just a second. 1 minus y square by 2 minus 2y, 1 minus y. Now you just have to simplify it and do it, that's all. 1 plus y square minus 2y by 2 minus 2y plus 2y square. So 0 to 1, so 5y square minus 4y minus 6y plus 1. Okay, now 5, so this would be 1 by 3 minus 6, this would be 1 by 2 plus 1. Okay, so this is the value what you get. Okay, so now I hope these are clear to you.
Sir, can you, sir, show me the plane, sir?
Show me.
That is equal to x minus 2y, sir.
If you want to draw it, so how would it look? So let me draw it in this way probably. Suppose this is x, this is z, let's say this is y. Okay, the plane is x minus 2y. Okay, so when so this would be like x, let me write z equals to y, x minus 2y. Okay, so now when we are looking this plane on, let's say, xz plane, then how will it look? So or let's see where it cuts at x-axis. Okay, so x-axis it will cut at, so when y is 0 and z is 0, so sorry, yeah, so
the plane will pass from
origin.
sir.
Yeah, so this is one thing, and then okay, so let me think at or how it will look on this xz plane. Okay, so that means that I'll have to put y equals to 0, so that would give me this line, z equals to x. Okay, and now let's say how it looks on this xy plane. So xy plane means z equals to 0, so x would be equal to 2y, so x would be something like this. Oh, so I think it's y by 2. Yeah, so it should be like this, something like this. Okay, and then we have on this plane how will it cut. So when I put x equals 0, so I'll get z equals to 2y or minus 2y. So how will it look? So z equals to 2y would be like this. Now I'll have to do the negative thing. I don't know how to draw it. So let me think. So it would be something like this. And then maybe you can join these lines. I don't know how to draw it properly. But how you can understand, like this plane is cutting this xz around this, so I mean the plane could be like this. So how should I draw this? I don't know how.
Sir, understood,
focus
sir.
on this. You understood? Like, so you have to basically how you have to see how this plane cuts these planes, and then you can draw a plane so that these lines lie on that plane. That's all.
Sir.
Yeah, so that would be one way to visualize this. And from here also, like, you can, instead of dealing with this double integral, it's like when you're calculating the volume, it's like you are doing like this kind of integral, like dx y z. So this is how also you can do. Then you will have to, again it will when you integrate with respect to z first, you will get this kind of integral only. Okay, I mean this integral.
Yes.
Okay, so that is one of the thing. Okay, let me move to the next problem. Three, four is, okay, so this is the problem. So find this the find. Okay, so you basically have to integrate. Let me write it simply. So evaluate this integral. This y d of xy, okay, over r, where r is the, because it's the semicircle, so it's like xy, where this 0 is less than equals y less than equal to 1 minus x square. Okay, so and x is varying from minus 1 to 1, so it's like the upper semicircle, that's all. Okay, so this is 1 0, this is minus 1 0 x y. Okay, so again you have to integrate over this, so again you have to do the same thing. So can you tell me how to write this integral?
Take strip parallel to x-axis, sir.
Parallel to x-axis.
Yes, sir.
Okay. But in this case, I think this the other way around would be much simpler. Don't you think?
Yes, sir.
Right? Because they, okay, so this can also be done. So over here,
Y is equal to
yeah.
0
So
then.
here you will have to write what. So y. So this is, you are saying that y is varying from 0 to 1. Okay, so y is varying from 0 to 1, and here it would be x is varying from 1 minus y square to minus of 1 minus
Minus.
y square.
Yes.
Right, so this would be,
So that will be simpler, sir.
the other would be simpler. So
Yes, sir.
so this would be like
Taking
this.
strip parallel to y-axis.
Yeah, and this is how the domain is written, I mean this one.
Yes, sir. Correct.
Exactly in that form. So so here I can say that my x is varying from minus 1 to 1, and this y is varying from 0 to root 1 minus x square. Again, so this is dy, and then this is dx. Okay, so now if I do it, this is minus 1 to 1, this is y square by 2, 0 to root 1 minus x square, and dx. So this is 1 minus x square by 2 dx, and then you have, so half you can take common, and then you have 2, correct, minus x cube by 3, which is minus 1 to 1. This is 1 by 2, this is 2, minus 1 by 3, so it's 2 by 3. 1 by 2, this is 4 by 3, it's 2 by 3. Okay. Okay, now, okay, so now let's come to this problem. Okay, so this is a bit interesting. So suppose you have to evaluate this integral 0 to 1 y to 1 cos x square. Okay, this is dx dy. Okay, how to evaluate this? Okay, so if you like to
But
do it
first, we need to integrate with respect to y, sir.
y and then with respect to x, right?
Yes,
Because
to
it's
change the
if
order of integration.
yeah, and it will make the task easier, right? So if I
Yes.
do integrate with respect to y, then I can see that some y times cos x square will come, right? Something like this if I integrate with respect. So obviously the limit will change, but this I'll get, and with some limit, right? And now it seems uh, that once I put, so this would be some function of x, some function of g, right? And then we could hope to get something better. Otherwise, if we want to do it directly, we don't know how to proceed here, because even if I do change a variable, something 2x is required, then I can do that, right? So how will we do this order? How will it change the order? So for
So first draw these are regions, sir.
yeah, so first we'll have to look at the region, like how this integration is done, right? So let me draw this. So this is your x, this is your y. Okay, so x is varying from y to x square. So what is this y means? Like this is the axis, y equals to x line,
X is equal to y
right?
to 1.
So now x is varying from y to 1. So let me say this is 1, this is 1. So it says that, let me close.
It's a vertical line, sir. X is
Yes,
equal to.
I'm just trying to write this figure first. Okay. Okay, so this is the, so it says that your x is varying from y to 1, so it's going upward, right? Okay, now, so this is how your x is going, and your y is varying from 0 to 1, so that means this region from here to here. Or did I made some mistake? Oh, I think I said it wrong. Your x is varying from y to 1, sorry. So this would be,
This is correct, I think.
no, x is varying from y to 1, so x should be like this, right? So x is varying from y to 1, and the y is varying from 0 to 1.
Yes, sir, yes.
Yeah, I think this would be correct. So this is what it represents. So this is the, let me write just one arrow. Okay, so this is what it represents, this integral. Okay, now what we'll do is, so this is the region, right? So our region can be, so this is the region where the integration is being done. Okay, so now we can visualize this integral, like we can change the order, and it would be like this, that my x is varying. So this integral, let's say I, would be like, now instead of changing
Y
my,
is varying from 0 to x.
yeah, so first let's look how this x varies, right? So this is the first that we should make sure. So x is varying from 0 to 1, so that's what we'll do. Okay, so I mean this is the integral over here. So x is varying from 0 to 1, and how does y is changing? Y is changing from 0 to x. Okay, so this is 0 to x, and this is cos x square. So now if we integrate this, so this is just like constant. Okay, so this is 0 to 1 cos of x square, and then you have x dx. Now you can do the change of variable, so you'll get, so let's say t equals x square. If I do, so dt would be x dx, right? So if I do this, so I'll get cos of t, and then I'll get dt by 2, and now the limit would be from 0 to 1. Okay, same thing. Now if I just integrate, so 1 by 2 integration of cos would be sine t 0 to 1. So this is half sine of 1, right? Okay, so now let's go to the next problem. So this is okay. So here you, so let me write in short. So here you have to just compute the area of this region. Let me draw here itself. Okay, so okay, so this is part of circle. Okay, so this is circular arc, so the radius is 1. Okay, so this is 0 comma 1, and these are the line y equals to x, and this is y equals minus x. Okay. So now you have to find the area of this region. Now how would you do this over here? So how should we proceed here?
So we need to integrate in two parts, sir.
Okay, here also it should be done in two parts, you're saying.
Yes, sir.
Okay, so how would you like to go, like vertically or horizontally?
Sir, I think vertically will be, sir.
Vertically, so this is how you're saying. Okay, horizontally if I do, there will be again the complicacy would be there. Like here it's fine, like in this part, but here again you'll have to do again. So this looks simpler,
Yes.
right? So as you mentioned, like we'll try to do it in the same way. So the area I would write it as, so first let's see that x is varying from, because I think the figure I made is a bit looks not so good. So because this is y equals to x, so I mean this is 1, so this is the 1, and this is minus 1, right? So maybe the picture I draw, okay, anyway, let's not make it circle. So I'll just write what this is. So this is x square plus y square equals 1. Okay, so now so the area is like, so first I'll vary my x, so x is varying from minus 1 to 0, and in that case my y is varying from this point, so this is y equals to minus x to this root 1 minus x square, right? This is dy and dx. Similarly for the other one, so this is varying from 0 to 1, my x. Okay, so x is varying from 0 to 1, and y is varying from x to root 1 minus x square. So this is dy. Okay, so this gives you, is this
Sir,
okay? Yeah.
sir, y is equal to minus x, sir, will it circle at, sir, minus 1, sir?
Sorry, y equals to,
Sir, what is the intersection point of y is equal to minus x and the circle x square plus y square is equal to 1, sir?
no,
So I think it is 1 by under root 2, sir. Minus 1 by under root.
is it?
Sir, put the value
Oh,
y.
okay. I think you are right probably. Okay, let me see. I think you are right. So this is, let's say, circle. So this is x square plus y square equals to 1, and then if I put y equals to x here, so I'll get x square equals 1. I mean, so sorry, 2x square. So x would
Yes,
be
sir.
1 by root 2. Yeah, you are right. So this would be, sorry. So this would be 1 by root 2, and this would be minus 1 by root 2. Okay. So I think my figure earlier what I made was correct. Okay. Yeah. Okay, so this is the intersection point. So here the limit would be minus 1 by root 2, and here it would be 1 by root 2. Okay, so this is, now it's just simple computation. So this is minus this plus x, and then dx plus 0 to 1 by root 2, again root 1 minus x square minus x dx. Yeah, and that's all. So you can probably club these two integrals together. If we can write it as 2 times, right, because it's symmetric. So I think you can write this as 0 to 1 by root 2 root 1 minus x square, and then here also I think this will add up, right? So this is x. If you do change of variables, I think you can write it as 1 by root 2 x dx, right? So or minus, sorry, right? So if I do change of variable here, so my limit would be from 0 to 1 by root 2 and minus will come, so I can write it as this. Okay, so now you can evaluate this integral. Okay, so let's go to the next problem. So up next we have this. So you have to evaluate the following integral. Okay, so this is x d of xy over r. Okay, so now r is this region xy in R2 such that 4 is less than equals x square y square less than equals 5. Okay, so this is basically the, what do you say, annulus, right? So it's like 2 circle. This is x square plus y square equals to 4, and this is x square plus y square equals to 5. Okay, so this is 2 0, this is root 5 0. So now you have to integrate this over this circular region. Now how would you do that?
So find this area of integral in first quadrant, sir. Then 4 times it will be the whole area.
Okay, so that is also true. Now, so you are saying let's evaluate the integral just on this one, but
Take what
don't
like.
want it. Is it correct? Like if you have to like consider the area, then I think it's correct that if you integrate on this region, like just take integral of 1 over this, let's say the first area dxy, and then integrate on the a, so this is, let's say, a, then you can multiply 4 to get everything, like the whole integral. But here you see this x is also there.
Yes, sir. Yes, sir.
Okay, so that we cannot do. So what could be the other
We
way?
have to split in, sir, 4 parts.
So you are saying we will split it into 4 parts, but we also know there is some polar coordinates, right? What you are
Because
saying is correct, that maybe, so let me first discuss that, as you are mentioning that but there also,
I think
yeah,
it is
so
not discussed yet, I think, sir.
where,
It is this, the sir, polar coordinate, I think, is not discussed.
in the lectures you are saying?
Yes, sir.
No, it has been discussed, that's why I chose these problems.
Yes, sir. So previous problems were easy by this, sir, polar
Haan.
coordinates. Yes, sir.
Here we'll just use the polar coordinates, and then the
Yes.
thing would be simpler, as you are saying. So if you try to look at this region, let's say, then here you can see that how would you define this, I don't know, like, so if you want to study this area, like, so just in Cartesian coordinates, if I want to see it, so let's just focus on the first one. A similar thing can be done for the second one as well. Okay, so suppose this is the area that you have. Okay, now how
Sir, what if, sir,
Mhm.
we find this, sir, the area of the bigger circle and the area of the smaller circle, and then subtract.
I mean,
So
here we are not talking about the area, but yeah, I think you can do that. So what you are saying is that we'll integrate x on this r, the bigger thing, and then
yes,
minus
sir.
this x, sorry, this is not x, x, and then the inner thing, right?
Yes, sir.
uh, in terms of area it's true, and here also it's true. Yeah, what you're saying is also true. Okay, so again, but okay, so if you want to do that way, then again, like, how will we write this one?
Sir, we can verify here, sir. That thing, sir.
What? Oh, you want to calculate in both way, you are saying, just to
Sir.
check. Yeah, it would be true. Okay, so if you want, we can do that. Okay, so how should proceed first? Should we do it in the whole thing and then?
Yes, sir. Sir,
Okay.
first find this, sir, is a bigger circle, and then
Yeah, okay, so let's try to do that. So, but again, like, how will you calculate for the bigger circle? So let's say this is s d1. Okay, so d1 is the bigger circle, and then x dxy. Okay, so now here, so what we'll do is, so
in
first
that
thing,
case,
so here, like, sorry, again, so here what you'll do, first you'll say that, so you will have to do it in this way, let's say. Okay, so here how will be split? So the first thing would be that I'll write my x is varying from -1 to 1. So I think I'm saying the other way around. So y is varying from -1 to 1, and how does my x varies? From root
minus under
1
root 1
minus
minus y square.
to 1 minus y square, right?
Yes, sir.
So here what, sorry, this is
I
not
use some
1, this
polar
is,
coordinates here, sir. So do not. It
yeah,
will be the
it would be
harder.
clumsy otherwise, right?
Sir.
So okay, so let's do with the polar coordinates. So I'll replace x by r. So r is what here? It's 5, root
R
5.
cos theta, na?
So it is root 5. So where is this? So I'll have this root 5 cos theta, correct? And now this r,
dr d theta.
okay, sorry, why I'm doing this? So this is r cos theta, and this is r dr d theta, and r is varying from 0 to root 5, correct?
5.
And then my theta is varying from 0 to 2 pi. Okay, so this would be 0 to 2 pi. So cos theta would be integrated. Let's integrate that. So cos theta would be sin theta 0 to 2 pi.
Root 5
So this will give you 0, right?
r square by 2.
So this is giving you 0.
Root 5, sir.
No, no,
Yes, sir. Theta is
yes.
very important. Yes, sir. Yes,
Yeah,
sir.
so this is 0. So similarly, okay, is it coming out to 0? Yeah, for the second one also it would be the same, right? The logic would be same. So I think the integral is going to be 0.
Yes, sir.
Okay, so I think this is not a good place to check it somehow.
Sir,
So let's do it y, right? So let's make a
sir,
change.
I don't, sir. Area is not, sir. We can see clearly that
No, it's
area.
not area. See, it's not area.
Sir.
It's not the area. We are doing something else. We are integrating this
Yes.
y or x, right? So,
Yes, sir. We are including some function.
so let's do it with y, because then I'll get non-zero thing, right? So y would be r sine theta, r dr d theta. In case if you want to just verify it, if you want, then what we'll get here? So this would be minus cos theta, right? And then 0 to 2 pi. But again, the same thing would come. It's periodic function, so anyway, it's not going to help. So okay, what we can do is, let's focus just on the half of the part. What do you say?
Sir,
So this will also be 0, right? It won't help.
sir, cos 2 pi is minus 1, na, sir? Oh, sorry, plus 1. Yes, sir. It will be 0, sir.
I mean,
Correct.
periodic function, so it's always
Yes,
going
sir,
to be
yes, sir.
0. So it's not or what we can do is, let's do,
Sir, we can verify this thing only, sir. This will be, sir, enough.
no, I mean, this is coming out to be 0, so it's okay. So okay, so this is 0 again.
Let's
For the
say
same
from another
d2
method.
also it would be 0. Okay, so if you want to do the second way, so second way would be that you are saying this y dxy. So this would be like you are saying r as
2
before,
to root 5.
r sine theta,
2
r
to root
dr.
5 are varying from.
Yeah, so r is varying from root 2, sorry, 2 to root 5.
Root.
So anyway, this is not playing a role at all. So when we
Yes,
put
sir.
0 to 2 pi, it's turning out to be 0.
Yes, sir. Yes, sir.
So
It will comes out to
okay,
be.
so this is 0.
Sir,
Okay.
can we try in sir Cartesian form, sir?
Cartesian, yeah, one can do it, but it would be very clumsy, that's all.
Just leave it, sir. Okay, sir.
Yeah, so
Let's
you
try
can try
to.
it out. It's just like
Yes,
you'll
sir.
have
Yes.
to do it in a
Yes.
partition properly. So maybe let's just, you if you want to just focus on this part, this, I mean the semicircle, you know how to deal with it.
Sir,
Similarly,
I
you can
think
deal
this
with
is
this as
sir,
well.
surface. I think this is surface integral.
Yeah, actually, if you want, yeah, it's like that, because again, like this is kind of
You are taking a
this
function, sir.
function
Yes.
we are taking, so that's like there is something above this, so above
Yes,
this
sir.
region. So this is like domain, and then we are doing that. Okay, so let's go to the next problem. What else? Okay, now this, what do we have? Okay, so this one. So compute. So this is a, I think it's very famous example probably. Compute the integral this minus infinity, or r basically, e minus x square dx.
Yes, sir. This is coming out to be root pi.
Hmm. So can you recall how do we show that? So basically, if you want to do it directly, then it would be difficult, right?
Yes, sir.
It's not actually, even I don't know any tools who can do it directly, as per my
Sir,
knowledge.
I think that
But mhm.
we have to consider two integral. I think then
Exactly, and that's how
at this.
root pi comes up. So you
Yes, sir. We have to take x square plus y square both, sir.
exactly. So
Then
let's call this area, or this integral, let's say I, to be this minus infinity to infinity e minus x square dx. Now this can be written similarly as, like in terms of other variable, e minus y square dy, like it's nothing different. So if I do I square, so it's like minus infinity e minus x square dx, and then you write minus infinity to infinity e minus y square dy. It just, we are using another notation, that's all. So now if I combine this together, so this is minus infinity infinity minus infinity infinity, this, let's say I'm putting this minus y square, so let's say e minus x square plus y square. Okay, let's say I'm writing it as dx and then dy. Okay, so now here one can use the polar coordinates, correct? So what I'll get is, so this is what, so this is whole r2, right? So if you want, let's write it in this way, r2 e minus x square plus y square, and then you have dxy. Okay, so now we are actually integrating on the whole r2, and we know that in polar coordinates we can transform this in the following way. So this x square plus y square would be just e minus r, so x is r cos theta, y is r sin theta. So x square plus y square is r square, and then this is r dr d theta. Okay, and now this r is varying from 0 to infinity, and theta is varying from 0 to 2 pi, right? And now it becomes very simple to evaluate this integral, because now you can again do a change of variable. So you can do, so let's say this is 0 to 2 pi. So anyway, this I can just write 2 pi, right, because it's independent of theta. And then I had this 0 to infinity. Now this minus r square I can replace by t, and then this would become dt by 2, and the limit will also be like that. So t equals to r square, so dt by 2 equals r dr. Okay, so if I do, I'll get this. Now this is 2 pi, this is minus t minus 1, 0 to infinity. So this is 2 pi, at infinity it's going to be 0, 0 plus, so what is that, plus 1, right? So did I do something wrong? Minus plus, it's turning out to be plus 1. Okay, so now this is It's some. Oh, so I missed this 2. So this 2 will cancel with this one. So I'll have this pi. So this is the pi, and this tells you that the value of integral I is nothing but root pi. Okay, but the thing is, why should it be root pi and not minus root pi? So this gives you two possibilities, that I could be plus or minus root pi.
Sir, we take sir area positive.
No, 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 no. We are not talking about area, we are just talking about the integral. And area could be negative, right? We do that. So the thing is that over here you see this function is positive. So you know that if f is greater than 0, then I know that my integration is going to be greater than 0, right? This Riemann integration. Right? This we have already seen, right? This kind of thing.
Sir, the integral should be sir unique, na sir?
Yeah, it is unique. So see, what I'm saying, that here there are two possibilities of I, but it cannot be root of minus of root pi, because I know my integral has to be positive, because my function is positive. So I cannot get root minus root pi, so I has to be root pi.
Yes, sir.
Right? So if you see the graph also, like how does this function looks? So it's in the probability what you see, normal distribution kind of thing, right? So it's like this. So at x equal to 0 it would be 1, and then it will slowly die down, and then here also. This is the curve what you get. So this is y equals x square. Now if you change the this minus, if you do, okay, so let me say this. So suppose let's say I am saying a evaluate this minus of minus infinity to infinity e of minus x square. Okay, now in this case, if you try to calculate this a square, you will get the same thing, right? A square is equal to I square, because this minus e minus x square with minus and then again minus, this will give you plus when you do product. Right? So this is same as I square. Now I think you must have understood. So
Yes, sir.
so this is equal to pi, but here a would be minus of root pi, right? But here it won't be root pi. Okay. Okay, then what else? Let me go to the 9th problem. Okay, where is that? Okay, so find the, okay, so this is the first part. So I'll draw a figure, find the area of R, where R looks like this. X, Y. So this is one of the point, and then you have two ones. Let me say this is 1, this is 2, this is 3, 2, 3. Okay, so the second point is 2 comma 1, third point is 3 comma 3, and this is 1 comma 2 somewhere here. Okay, so this is the picture that you have. Okay, so now you have to compute the area for this region. Okay, so let's say this is R. Let me say this is R. So this is the first problem. The second one says that also compute this integral, which is R ex dx dy. Okay, so now, so let's just focus on the first part. Once we are done with the first, the second one is just as easy. So now how will we solve this first part? So one is the very obvious thing what we were doing earlier, right? So how will you deal with that? So what would be the first step?
Sir, what? Yes. So find this equation of the lines.
Okay, so the first thing is that we need to find the equation. So what is the
Yes.
equation for this one? This is y equals uh,
2,
x by
2x.
2. No, x by 2, right?
X by 2.
So it's like
Yes,
x
sir.
equals to 2y, and this would be y equals to 2x. This is y equals 2x. Okay, what about this one? So this is y minus 3, or let me say y minus 1 upon 2 is equals to x minus 2 upon 1. So this gives you y equals to 2x minus 4 plus, so this is y equals to 2x minus 4 plus 1, which is minus 3, right? So this is y equals to 2x minus 3. Okay, what about this one? Again we'll do the same thing.
Y minus 2 by
Y minus 2 by
1.
1,
Yes,
x minus
x
1
minus
by 2.
1 by 2.
So this will give me y equals okay, so this is
2
x
y.
equals to, let's say x equals 2y, again minus 3, right?
3. Yes.
So x equals x, or let me write it this way, 2y minus x minus 3 equals to 0. So let me write all the equations in the same way. Okay, so okay, we will discuss. So what should be the first step? The first would be that the usual thing what we were doing earlier, right? So how will we do this?
Sir, take a line horizontal strip, sir, parallel to x-axis.
Okay, so if you want,
Then
so
we have, yes.
so this would be one way, right? As you are saying that you can split it in this way, right? So the, okay, so let me do it in the first way. So this is the first, which is the obvious way to handle this problem. Okay, so this a would be, so first I'll have to take this x is varying from 0 to 2, right? So okay, so let me write this. So okay, so we are varying like this way. Okay, so that means we are taking y to be varying from 0 to 3, but in between we are breaking y, so y is being broken over here, right? And then here, so at 1. So first let's see that from 0 to 1, okay, dy. So how x is behaving? So x is going from this 2, a y by 2
Y by 2
to
to x 2y.
2y, right? So this is dx dy. Okay, then plus about the second one, if you want to look, just a second.
Sir, y is going from 1 to 2.
Yeah, and then y is going from 1 to 2, yeah, and then x is going from
Y by 2
y by 2
to y plus 3 by 2.
y plus 3 by 2. This is dx dy, right? What about the
Right.
third one? Third one is going from
Y is going from, sir, 2 to 3.
2 to 3, and x is going from
2 plus 2y plus 3.
minus
3
3,
plus
right?
no, sir. 2y minus 3. Correct.
2y plus 3 by 2
Yes.
dx dy, correct? Okay, so let's try to evaluate this. So this is 0 to 1, this would be 2y minus y
3y
half.
by 2.
So 3y by 2 dy. What about the second one? This is y by 2 and y by 2 will get
Y
cancelled,
will
right?
cancel outside 3 by 2.
3 by 2 dx. What about the third one? Y plus 3 by 2
Minus 3y
minus 3y by 2
minus 3.
minus 3 by 2, right?
Uh,
No, plus, no, it will add up. So 3 by 2 minus
Add
plus
up,
3
yes,
by
sir,
2,
yes,
right?
minus,
So it would be
correct.
plus.
Plus 6 by 2.
So that is 3
Yes.
dy. Okay. Okay, so now this is nothing but, let's try to compute this. So this is 3 by
3
2,
by 4.
1 by
4.
4, right? Am I right? Y square by 2. Sorry, it's
Yes,
not.
correct. Plus 3 by 2.
No, it's y square by 2, right? 3 by 2 I take common. Y square by 2 will give me 1 by 2.
The- yes, sir.
3 by 2
3 by
times 1 plus this is, so minus 3
take
by 2,
3.
let's take outside, then this will give me 9 minus 4 by 2, correct? Plus 3. So this is 5 by 2. So let's take LCM to be 4. Then I'll get 3 plus 6 minus 15 plus 12, correct? Then I'll have this 12, 3, this will go, so 6 by 4, which is 3 by 2. Okay, so this was one obvious approach. Okay, but if we look at this thing properly, okay, so see what's the advantage over, so this is one way. Okay, so let me just copy this picture. Okay, so if you see this picture, so it says that these, if you, let me rewrite this one. Okay, so it's y equals to 2x, so 2x y minus 2x, sorry I forgot what was the equation. Let me write first here. So it's like y minus 2x plus 3 equals to 0. Okay, or let me write in this way, y minus 2x equals to minus 3. Okay, so let me rewrite all these equations. So this also can be written as 2y minus x equals to 3. Okay, so
This is a parallelogram, sir.
this is a parallelogram, so that I can translate it, right? So what was that? So this is 2x minus y, I can write it as 3. So this is also 2y minus x equals to 0, and this is 2x minus y equals to 0. So what does this says? That this line and this line, okay, just the translation of these two, right? This is what these two equations tells us, correct? Similarly, these are just that translation of this line 2x minus y. It has been just translated by 3 unit. So if we define this change of variable, okay, so let me define u equals
2y minus x.
You understood? So okay, so if 2y minus x and v equals to 2x minus y, then what will be the resulting figure? So it says that u, which is 2y minus x, is varying from 0 to 3. So let's say this is 3, this is 3 unit, correct? So can you see that this figure will be transformed to this figure? Yeah.
Sir, can you elaborate, sir, it
This
little
one?
bit more?
Okay, yeah, sure. So see what I'm saying, once I do this change of variable, v equals to 2y minus x, okay, so now let's look at this thing. So it says that 2y minus x is varying from 0 to 3 in this region, right? So if you look at this region, I mean this is when you are going, so this 2y minus x, okay, so let me rewrite this. So this region R can be written in this way as well, right? So x y such that 0 less than equals to 2y minus x less than equal to 3, correct? And your y is varying from, oh sorry, this interval is 0 less than equals to 2x minus y less than equal to, less than equal to 3. This can be thought of like this, right? This region R.
Sir,
Or if you,
2x minus y, sir, there are
okay, so
two limits for 2x minus
let
y.
me explain in this way then. See, okay, so this region you can think it of like this, made up of a strips line, straight line this, and straight lines like this. You can think it like this, right?
Yes, sir.
So now this, how these lines are varying, it's varying from 0 to 3 unit, and this line, this is how you do in polar coordinates as well, right? So if you do this, if you represent this x y, okay, so this is r and this is the
But
theta.
there is a gap, sir, between sir x-axis and sir the line joining 0, 0 to 1, sir.
Yeah. So I'm not talking about this one. I'm not talking about how x and y are varying. I'm saying how this variable. So if you consider this u and v, so I'm not saying x is varying from 0 to this. I'm saying 2y minus x, the difference is varying from 0 to 3. That means this line, these horizontal lines, not horizontal to x axis, but it's horizontal to this line, 2y equals to x, right? So I'm saying this line, okay, this is a line, okay, this line is translating from 0 to this 3 till 3 units.
Yes, sir.
So this I
Yes,
am
sir.
saying in this way so that you can understand that this variable, how this is varying. That's all. It's similar to what you do
So
usually,
this
like,
always works, sir, no, sir?
uh-huh.
This method always works, sir.
Which method?
Because there are some problems when translating, sir, these variables and then finding the sir, limits is very sir, difficult, sir. Finding the region, sir.
Okay, I'm not sure about what you're saying, but okay, anyway. So this is kind of like when you have this kind of structure, like which from where you can see that if I do something, if I do some change of variable, then it will reduce to a simpler problem.
Sir, is there any analytical way, sir, to find limits, sir? Limits of
Limits, as you're
u
saying,
and
integral.
the u and limits of sir, how to
Okay,
sir,
okay. How this u and v will vary? It will depend
sir,
on the question, right?
sir, how the region will be sir, defined, sir? Is there any analytical way, sir? This is sir, your sir.
It depends. Like, okay, so if you're describing it as an abstract function, like,
Yes, sir. This
I
is
don't know.
your visualization, sir. Na? You
I
is
understand. So
there
I
any
think,
sir concrete way, sir, to write these limits, sir, or to sir
and
describe the sir
mostly,
region, sir?
so suppose like you are saying, let's say this is fxy equals to c, and the same function, this is fxy equals to d. So that's the main thing over here. So I am just talking about the parallelogram. I don't know about how to go in general, but you can see that this fxy is the same function which is like being translated from here to here, and the same function on the
Hmm.
other boundary, so suppose gxy is being translated from some point to some other point. So let's say this is a, this is b. In that case it becomes very easy, but in abstract I don't know like how it's more like I cannot, I don't think there should be any general settings where you can do.
Sir, sometimes we sir put u is equal to x y and v is equal to some sir x square, sir.
Yeah, I understand, but that's totally depending on the problem. I mean, how the region is being given to you.
So is there any sir a general sir approach?
I don't think. I mean, I'm not sure. Maybe in simpler domains you can do, but not in general. Even for two integral you cannot have like this r. I mean, you cannot always break. So like it has to be a simpler, so that, how should I say? Like as you can see in this case also, like where, okay, in this case also it becomes very complicated when you try to do in the Cartesian product, right? So this kind of thing that you understand, like when I'm trying to evaluate this integral, okay, what do? We say that x is varying from somewhere to somewhere, which is kind of constant, and then we are saying y is varying from something to some function, some gx to y, some hx, right? In this kind of domain only we are doing this double integral.
So, sir,
In
we
general,
have, sir, limits of, sir, x and y, sir.
okay.
So, sir, by the using of those limits, can we not find these limits of u and v, sir?
Okay, so you tell me what kind of domain you are saying. So suppose R you are saying is given to you, how I mean, how is this R looks, how does this R look? Then probably I think it mostly, I don't think in abstract, like just for any kind of function, I don't know, maybe. So you, if
Yes,
you
sir.
give me some example, then maybe I can think a bit, but I
Yes,
don't
sir.
know.
Yes.
So region has to be given, otherwise it won't be easy. I feel so. Okay. So in this case, actually, the main thing is that I know that this is kind of parallelogram. I mean, if I do some transformation, kind of, how should I say, that it looks like rectangle. In so okay, so I think this would be, I mean, this motivation. So if you think of this one, sorry, let me draw it exactly like this. So what we are doing basically over here is like this. So this is the figure in this xy coordinate. Okay, now my coordinate system is changing like this. Okay, although it does not looks like parallelogram, do it in this way. Okay, so now my new coordinate system is like this. So this is my new x, this is my new y. Now in this situation it would be a square kind of thing, right? This is what we have done here, nothing else.
Yes, sir. Sir, I have, sir, example if you can discuss here.
Yeah, sure, we'll discuss it. So let me first complete this one, then we'll discuss. Okay, so how, okay, so now how will we do this, evaluate this a? So a would be like this 0. So now this is varying from 0 to 3 u, and this is also varying from 0 to 3. And what function did I have? Okay, it was just area, so it is 1. Now I have to calculate the Jacobian and then du dv, right? So what is the Jacobian over here? So j would be, so first I'll have to write x and y in terms of u and v, right? So from here what will be my x? X would be, so just multiply by 2 in the second one, so du plus 2v, and then add then 3, right? 4, yeah. Y would be 2u plus v by 3, same thing. Okay, so the Jacobian over here would be, so determinant of, so this 1 by 3, 2 by 3, okay, and then okay, and then over here what we have, this is 2 by 3, and then this is 1 by 3, so this would be 1 by 9 minus 4 by 3, sorry, 4 by 9, this would be minus 1 by 3. Okay, so this a would be, so this is 0 to 3, 0 to 3, and then you have 1 by 3 du dv, so which gives you 1 by 3 times 9, this is 3. So this is the first part. The second part is just, we'll do the same thing. So ex dx dy, so r, so I'll just use this transformation what we did here. So it's 0 to 3, 0 to 3. Instead of x, I'll write this as u plus 2v by 3, and then I had 1 by 3 du dv. So this is 0 to 3 e 2v by 3 dv, and then you had 0 to 3 e of u by 3 du, and 1 by 3. Okay, so I think here I got 3 by 2. Why am I getting here 3? There's something wrong. Why did I get here 3 by 2? I think there is some
Sir,
computation problem.
you have calculated the last integral, sir, in very, sir,
This one?
small step here. No, sir.
No, no, I
The
am saying
three by where you got 3 by 2, sir.
here you are saying.
Yes, sir. The last integral, sir. 2 to 3 minus 3y by 2 plus 3, sir.
Hmm. So that would be minus 3 by 2 and then y square by 2. 2 to 3. 9 minus 4 by 2. It's okay, no? This seems okay. This seems okay. This seems okay. Y square by 2, that will give me 1 by 2. 4, 3 plus 6 minus 15 plus 12. 6 by 4. Something I think I missed out. I don't know. So I'll check before uploading it. Okay. So I think either here something is wrong or in the next part. I'll check this one. Okay, because the answer should be the same. It should not be different. Anyway, let's say this. So this would be e 2v by 3 and then 3 by 2 0
Sir,
to 3.
I am getting, sir, minus 3 by 4, sir, from last part, sir. Last
Here,
integral.
here. Oh, here you are saying.
Yes, sir.
So you are saying this is not 5 by 2 will come.
Sir.
Why so? So if I take minus 3 by 2, if I integrate y dy, what will I get? Y square by 2, right? This is 2 to 3. Then so minus 3 by 2. So let's take 2 outside, minus 3 by 4. This would be 5. 9 minus 4, right? 5. This seems okay. Yeah?
Yes, sir. Correct.
Okay, I'll check it. No
Will
issue.
be, sir, minus 3 by 4, yes.
I think you integrated y. I mean, I think.
Yes, sir. Whole thing, sir. Yes. Minus 3.
I'll check. I don't think that it should not be like this. I don't know what the actual answer. I believe this should be correct. This is much easier. Minus 1 by 3, 9. This seems to be correct to me at least. I'll check this one probably. Well, this is quite simple. You just have Jacobian. Jacobian seems to be 1 by 3. No issue with that. I think this seems to be okay to me. I'll have to check this part probably. Okay, I'll check it. Before uploading it. Okay, so we have this, and then you have over here you have this 3 by 4. Oh, sorry. This is u. This is 3 e raised to the power u by 3, 0 to 3, and 1 by 3. E square minus 1, and then you have 3 times e
3 will
minus
cancel out,
1
sir.
by 3, 3 by 2, e square minus 1, e minus 1. Okay, so this is what you get. Okay, now maybe you can tell what question did you have.
Sir, integrate, sir, sign of, sir, x minus y by x plus y, sir.
X minus y upon x plus y.
So double integral, sir. This is double integral.
That is fine. Dx dy.
So where region is, sir, given by, sir, bounded by this coordinate axis, and x plus y is equal to 1 in the first quadrant.
X plus y equals to 1. This one?
Yes, sir.
So this is 1 0. This is 0 1. Okay. Okay. So here we have to use some transformation, you are saying? Or What do you want to do here?
Sir, we will, sir, write, sir, x minus y is equal to u and x plus y is equal to v, sir, by taking some transformation, sir.
Okay, so now you want to know what will be the resulting area
Yes, I
coming.
want to recognize this
Okay, okay, I
region, sir, by
understood. I understood your point.
transformation.
Okay, so
After
this
the
is my
transformation.
r that is given to me, and now I want to know what will be the r prime under the transformation. U equals to x minus y and v equals to x plus y, right? Okay, so
Yes.
in this, sorry, so in this case what can we do is, so this I know, this is x plus y equals to 1, equals to 1. So maybe here if you want you can do, so let me see how this x looks. So x would be u plus v by 2, right, and y would be v minus
U
u
minus.
by 2, correct? So this is how these coordinates are related. Now this region, okay, so how can I describe this region? Here this region I can describe it as r would be like that my x is varying from 0 to 1, let's say, okay, and how is y varying? Y is varying from, so I am writing in this fashion, and y is varying from 0, y 1 minus x, correct? If I use
Yes.
this kind of variable over here, so this says me that my x, which is u plus v by 2, is varying from 0 to 1, and this y v minus u by 2 is varying from 1 minus x is u plus v by 2, right? This is same as saying that 0 less than equals to u plus v less than equals to 2 less than equals to v minus u by 2. So let me say, so this would be 2 minus u plus v. Okay, so u plus v from here can I reduce to 1? What you can do is, should I write it another way around? Okay, so this way also you can think of if you want to use the previous idea. Let me think. So this says that this x plus y is varying from 0 to 1, correct? So this tells you my v will vary from 0
0
to
to
1.
1.
Okay, so we got one thing. Now for the other one, so let's see how x minus y behaves. So x minus y would be, how should I look x minus y over here? Okay, so anyway let me just say, so v would be, so this is v is 1, so this is where the v will be lying. Okay, now let's come to the second thing. So it says that my x minus y, so x minus y is this kind of line, right? This is my x minus y kind of line, I mean x minus y equals to 0, this is. Now can I think this as, so x minus y is varying from, this is x minus y equals to 1, am I right? X would be 1, right? And this would be x minus y equals to 1 or minus 1, am I right? X, if I put y equals to 0, x equals to 0, y will be 1, right? So now this is the other thing that I can think of. So this tells me that v u will vary from I have to take order into consideration. This will tell me V is varying from 1 to -1. Sorry,
So
that
this
is wrong.
region comes out to be a triangle, sir.
Yeah. Sorry.
This region comes out to be triangle, sir. To be a triangle, sir.
Oh, you are saying the resulting region.
Yes, sir.
Yeah, there will be some restriction as well.
Sir,
Okay,
yes, sir.
maybe
Sir,
here
the
when I am saying this,
two lines are, sir.
this I am
One is,
saying.
sir, V is equal to U and V
No,
is
no, I am
equal to
saying,
Y.
see, when I am saying that this lines is forming this, I am putting a constraint as well, right?
Yes, sir.
Right, so just a second. X plus y. This is immediate, that this is going to be there. That is for sure. Now,
Yes, sir. Correct.
this is perfect, but here I think there is something I have to do. Just a second. So, x minus y. Okay, so maybe I can think in this way as well. So when I'm saying this v is varying from 0 to 1, I'm saying this is my coordinate, right? This is my v coordinate, correct? When I'm going to look for u coordinate, it should be like this. Okay, yeah, this could be a better explanation.
Yes, sir.
So now you can clearly see that how this will look in this uv. So now we need to find, so let's just focus on this thing. Okay, so now this v, sorry, I think I draw at wrong place. This v, it should be here, sorry. This represents v equals to 1, right? So the v coordinate should be here. Okay, so this is my v. Okay, and now you can think this v is from 0 to 1. Okay, and the u is varying from here to here. So if you want, you can take u coordinate to be here if you want. If you don't want to write this one, so I wrote earlier this kind of thing, right? So to escape this, maybe I can write this as this thing. Let's take my v u coordinate over here. So this is u equals to, okay, let me just
X minus Y.
switch this off. Okay, so this is u, and this u, as per this one, this represents what line? X minus y equals to 1, right? So now if I want to take this as u, then this would be the figure in the resulting axis. So if you want, you can, just to remove the confusion, you can remove this yellow lines. Okay, so but you'll have to think what this points are. So let me just write. So if I'm saying this is my 0 0 in this new coordinate, then what would be this point? This is 1 comma 0, right? And this would be 0 comma 1. So remove this extra lines. Yeah, now I think we can see this in terms of uv. Now you can define this region, right? So first we need to just to make sure what are the points that we have over here. So this looks triangle in this uv plane as well, right? Now what will be the point over here? So this says that it's something like, so this is u coordinate, u when v is 0. So this was, what was this line? X minus y, what was this line? X minus y equals to 1, right? No, or minus 1. What was this line? Do you remember? Oh, here only I have written x minus y equals to 1, right? So now this tells me this line I can write it as in terms of this u. So what will be this point? This would be v is equals to x plus u equals to x minus 1, x minus y. So this tells me this is 1, right? So this is 1 comma 0. What about this one? So this line say, what was this line? So this was my x-axis, this was my y-axis earlier. Okay, so what will be this point? This is simply going to be, so this represents,
So this was origin, na, sir? Previous.
this was origin in the earlier one. So x equals to 0, y equals to 0, right? If I substitute it, okay, so this was in the previous coordinate, this was 0 0, but in the new coordinate what will be this? So where is this transformation? Yeah, from here you can get this, right? So u equals to 0 means x equals to y. Okay, so you solve this. U equals to 0 gives you x equals to y, correct? V equals to 0 gives you x equals to minus y. Now when you solve this, what will you get? 0. Sorry, why I am doing this? I should do the other way around. So x equals to 0 will give me this, u plus v equals to 0, and y equals to 0 will give me v minus u equals to 0, right? But what will this give me? U equals to v, and this will give me u equals to 0. No, something is wrong. What error am I doing?
Well, I have the region, sir. Can you write this? Then we can think, sir. Right.
No, this region should be like this, right?
Yes,
This is the
this is
region what you
correct.
have.
But
Now you have to
process-
write in terms of u and v. That's all. So once we get these points, then we are done. And
Sir,
I believe
we-
this is going
sir-
to be just a second. Okay, let
Sir.
me just write it on my guess. So this is 0 1, let's say, and this should be 1. Just a second, okay. Let me just write this
Okay.
one. So what was this line earlier? This was x plus y
X
equals
plus y
to
is
1, right? This was my previous line. So now I have v equals to 1 over here. Okay, now this will tell me this will v equals to 1, and this point I need this kind of thing. So what was this line? Okay, so earlier this was, so what is this line? Okay, in the
X
previous
minus y,
coordinate,
sir.
this was x, what was that?
Minus y something, sir. Parallel to the u.
Okay, parallel to u, so this would be x minus y equals to
Lambda some.
no, let me write it precisely. So earlier what was this point? This point was 0 comma, like this was the y-axis, right? If I am not wrong. So this was 0 comma 1,
1.
right? So what will be this line in x y terms? So x minus y equals to 1, right? So if I put x equals to 0, no, minus 1, correct? So this will give me that u equals minus 1. Or it's like, just a second, it's
So
like
minus 1 कहाँ से आ जाएगा?
something u equals to, this was turning out to be x minus y equals to minus 1.
Sir, the slope will not.
Yeah,
will
yeah,
not
that and oh, what?
Sir, is this line correct, sir? X minus y is equal to
Okay,
minus
let me
1,
see.
sir.
So when I put x equals to 0, this gives me y equals to 1. Right. So I think this line is correct, right? Isn't it?
Correct, sir.
And this was x minus y equals to 1. This one, oh, sorry. This was my x minus y equals to 1. So this tells me that this would be v equals to this sum. I think I am doing something wrong. So this is telling me that this will be v equals to minus 1. Okay, so I think this would be the my v axis. I think I earlier what I did was correct probably, but
The
okay,
u
okay,
is
okay,
equal to
okay.
minus 1.
Yeah, so this is, oh sorry, this is u equals to minus 1. Okay, and I think this would be the axis. So this is my v is in this direction. So sorry, is this u or v? This is v, no?
Sir, x plus y is equal to 1 is sir v, sir.
Okay, so
X plus
this
y.
is u equals to minus 1. Then this was what?
Yes.
This is, now I am writing v equals to 1 over here. Something I missed. So this was also, this must be u equals to something, right?
U is equal to x minus y.
No, I think I messed up something. Okay,
I
okay,
think
see,
you have taken u is equal to 0, sir, this line, sir.
No, this is
Sir.
my u axis. I think I
So u is equal to 0, na, sir?
no, this means v equals to 0, right? Why u equals to 0?
Yes, sir.
Okay, so I think I messed it up something. Let me just rewrite it again. This figure, just a second. So this in yellow line we had this line. Okay. This was my x plus y equals to 1. Okay. So I defined it as v. So this is v equals to 1 in my new coordinate. This is my, oh, there only I am doing something wrong. So this is v equals to 1. That means this is my v axis. Okay. Okay, understood. This should be u. So this line was x minus y equals to 1, correct? This x plus y equals to 1. This yellow line. And this I am defining at v. So v is equal to 1. That means v will be this straight line would be v equals to 1 in this new coordinate system. Okay.
Yes, sir.
And now, okay, so this is v equals to 1 and this is v equals to 0, this line, that is u axis. And now let us look at the other one. So this was u equals to minus 1 and this was u equals to 1. This one, where is it? Yeah, so this was u equals to minus 1. This is u equals to minus 1 and then this line was coming out to be u equals to 1. Okay, so but correct, so v axis, no, I am messing this up. U equals to 1 means, okay, that means my v axis would be here. Okay, so I got it. Now this is my u. So this is my new coordinate u. This is v. This is u equals to 1. This is u equals to minus 1. Okay, and this is v equals to 1. So let me rotate this. Did I rotate it wrong way? I don't know how to do it. Let me rotate it this way. Yeah, this looks fine. Okay, let me see. So this is my v coordinate. This is, where is it? This is u equals to 1. I also got confused. Okay, whatever, I don't care. So let me just look at the point, that's all I need. Okay, so now you can think of this origin remains the same. Okay, this is what I was doing mistake. So origin would remain the same because you see x equal to 0 will give me u plus v equals to 0 and y equals to 0 gives me u minus v or v minus u equals to 0. right? So this tells you, if you solve this one, you will get u equals to v equals to 0. So origin is not going to change. So this will be still this, okay? So origin is still this one, and now these are the lines, u equals to 1, u equals to minus 1, and this positive u axis in this direction, okay? So now you can clearly see what these points would be. So we want to know about this point, sorry. So this point would be what? I know that my u, so I'm also getting confused. So if I draw it in a different paper, okay, let me write here itself. So this tells me that u will be 1, okay? I'm writing the first coordinate as u, okay? And what will be v here? V would be, where is it? V equals to 1, right? These two lines are intersecting at this point. Similarly, over here, what will be u? So u is equal to minus 1. So this point is minus 1 comma, and what is v? V is equal to 1. Okay, so you got these 3 points. Okay, so if I draw it in uv region, suppose this is u, this is v, then I am saying the first is origin, okay? The second one is 1 comma 1. So this is, let's say 1 comma 1, and the third point is minus 1 comma 1, which is this one, right? So this is the transformed figure, sorry. Okay, so this will be the region, the new region R prime. Is this fine?
Yes, sir.
Yeah. So I was earlier I was confused because of something, but anyway. So now this can be transformed into this region, and then you can deal with it. Okay. Okay. So as I was saying, that you just think of this as whatever. If you have this kind of line, here what I did is the same kind of thing. I treated this line. So I am filling this by these. I mean, as I mentioned, that I am considering this as one of the my axis, like these kind of lines, just like before. And then I need some perpendicular to this axis, and that to know the point, you just use this kind of substitution, that where my origin is going. Once you know where your origin is going, then you can determine where the new origin will lie. Okay, and then that's it.
So what will be the limits, sir? Limits of the integration, sir?
That you can write, right? So okay, so if you have this, so if first you'll have to write the equation for this line, right? So this is y equals to x, this is equals to y equals to minus x, right? And these are the two things, and this is y equals to,
Sir, in
sorry,
terms of, sir, u.
sorry. So this is u equals to v, and this is u equals to minus v, and this is equals to v equals to 1, correct? So now if you want to write this region, okay, let me delete all this. So this region can be written as, this integral. So this is sine.
This is clear now, sir.
Now you write the Jacobian, you will just find it out.
Yes, sir.
Okay, something du dv. Now here what will you do? You will write
Jacobian is, sir, 1 by 2.
Sorry?
Jacobian is 1 by 2.
Okay, Jacobian is 1 by 2, then you write it 1 by 2. So, okay, let me write first J. This is 1 by 2. And your limit you can clearly see. So, how will you write? As per your choice, what you want to write. So, do you want, if you want to go like this, then your V is varying from 0 to 1. And so, when you are going above, your X is varying from, or sorry, U is varying from minus V to plus 1, right?
So V is varying from 0 and U is varying from minus V to V. Yes, sir.
Correct. So this would be the transformed integral.
Yes, sir.
Okay.
This is coming out to be 0, sir.
Oh, okay, maybe. If you do this integration, you can get it.
Yes, sir. This is 0.
Okay. Okay, so this is how you can do this kind of thing. Okay, now Okay, so let's move to the next problem.
Sir, sir, I have question, sir. Is there, sir, any, sir, concrete way to find, sir, the transformation, sir?
That's
Sir,
what I
that
said. I don't know like any abstract formulation. There may be
yes,
like I'll have to look into some book probably, but I don't know like.
because this was, sir, simple, sir.
I
They,
can understand. But like if suppose the question is being asked where you have to do some transformation, I think it should be a bit easier. I mean, it should be obvious when you look at it, I think.
yes, sir. Like previous one.
Previous one here also you as you said that you want this kind of substitution over here, right? And you see
Yes,
the region how it was given, it's also like x plus y, like this region was given.
yes, sir.
So in this kind of thing you can do, but in general I think it's not that obvious. Like even if I change something, if I even if I change the region, it would be very cumbersome for you to do. So suppose instead of this region I give you this region, then how will you do that?
Yes, sir.
Right. So whenever I think you will get a question, it should be doable in some sense. Okay.
Right, sir.
Okay. So what else? So the ninth. Let's go to the next problem. Okay. What else? Go find the volume. Okay. So again, this kind of find volume of the region are bounded by the planes z equals to 0, x equals to 0 and y equals to 0, x plus y plus z equals to 1. Okay. Okay, so you have to find the volume of this region. So what you can do is, okay, if you want I can draw the picture. So volume means like you have to compute this triple integral 1 d of x y z, okay, over the region R, which I'll draw. Okay, so maybe you can give it a try. I'll just come in a minute. Okay, you just try to solve it, I'll come. Okay, so did you find the region? What the region would be? Okay, you tell me when x, how, where will the point, the plane intersect in xz plane. So when you put y equals to 0, what do you get?
At 111.
So x plus z equals to 1, right? When you put
Yes,
y
sir.
equals to 0, so it will be like this. Sorry, When you put y equals to 0, again you will get this kind of y plus x equal to 1. And similarly here also you will get this. Okay, anyway. So these are the points 1, 0, 0. These are points 0, 0, 1. And this is 0, 1, 0. Right? And these are the boundation that you are covering only when x and y and z all are, I mean, these planes. So this is the region what you have. So this region, okay, this region, and everything like inside this. It's bounded by 3 walls, and then you put a triangle on that. Okay, so this is the region that you have. Okay, so how do we solve this one?
Sir, put z is equal to 1 minus x minus y, sir.
Correct. And
Then
okay, so z, you are saying z is varying from 0 to 1 minus x minus y, right?
yes.
Okay, that's true. So okay, so let me say something is there, but first I am integrating from z, which is from 0 to 1 minus x minus y dz. But what about dy and dx? So how do
0 to 1 and x is also varying from 0.
sorry?
So both y is varying from 0 to 1, sir, and x is also varying from 0 to 1.
No. See, okay, so what you have done is like you look at the cross section probably, then I think you'll understand. So if I cut this, so you know that z is varying from here to here. Okay, like this you are around this plane. Okay, now if I see this, how should I do this cross section? Okay, you look at this base triangle, that would be one of the cross section that you have, right? So x and y will be chosen from here.
Yes, sir.
Okay, so it's like earlier we discussed this, right? That I mean earlier when, so suppose this is the domain that I have, and then f is given to us, f of x comma y, which is z here. So okay, so this you can think of this. What is this? Let's look at this. Is like
This
the
is 1
function
minus
1
x
minus
minus
x
y.
minus y, right?
Correct.
So this is representing this function, and then you have to think how to integrate in this region, right?
We are taking projection of the thing in xy plane, sir.
Sorry.
So we are projecting this
Correct.
region
You can, yeah, it's exactly projection. Okay, so whenever you have this kind of problem, like what you do is you look at the projection what you have on the xy plane, or you can do the other way around. It's not like that you can just put z, you can write x also in terms of y and z, and then you do projection on the yz plane, right? So it's the same thing. So over here as you have chosen z, so I have this z, and now we'll look at this one. So this region we have to focus. Okay, so as you have mentioned, how will this x and y
the
will
line
be?
is, sir, x plus y is equal to 1, sir.
Exactly. So this line is x plus y equals to 1. So if I want to vary in this way, suppose, then how will I write? So this y is varying from 0 to 1,
Y is 0 to 1,
and x is varying from 0
0
to
to
1
minus
minus
y.
y. So 0 to 1 minus y dx, and y is varying from 0 to 1 dy, right? So this you can integrate 0 to y, 0 to 1 minus x minus y dx dy, 0 to 1, then you have 1 minus y minus x square by 2, which is 1 minus y square by 2, then minus y, 1 minus y, this dy. Okay, and then you can just 0 to 1. What should I do? Well, let me write 1 minus y, this is 1 by 2 minus y square by 2 plus y. Okay, and here you have minus y plus
Sir,
y
you
square.
can directly, sir, integrate, sir.
Yeah, but here it was product, so that's why I am writing this way. Yeah, you if you whatever comfort you feel like you can do it. It's not an issue. 0 to 1, this y will cancel. So you are left out with this y square by 2, and then you have minus y plus half this dy. Okay, now you just integrate, you will get something. Okay.
So 0
Sorry?
coming out to 0, sir. Okay,
0?
we have to integrate first. No, no, sir.
It should not. Okay, let me do. So 1 by 2, 1 by 3 minus 1 by 2 plus 1 by 2. So it will be 1 by 6.
6.
Okay, let me see what problem I have next. Okay, again there is one problem. Okay, so let me write. So this says that find the volume of cylinder x square plus y square less than equal to 1 below the plane z equal to x. Okay, so again you have to, let me draw the picture first. So okay, is there no restriction? Okay, so this is the cylinder that you have. So it's about x and y, right? So x square plus y square less than equal to 1. So z is varying from, so let me denote it like, so let me say okay, so let me see, this is, so this radius is 1, okay, and this is varying in the whole z axis. This is how this cylinder looks. Okay, but this is not the region that we have to consider. So this is x, y, so this is z. Now you have to cut this by x equal to z. So x equal to z is like this line on this plane, and then you have to take up, so this is the x equal to z line. Now you have to take a plane, so that means you basically, this is like this y. Okay, so this is the kind of plane that you are cutting this cylinder with. Okay, so I don't know how to draw it properly, but you understand, this is the kind of thing that you are cutting this cylinder by this plane. Okay, so anyway, so what you have is this kind of structure will be left out, right? So over here something will be left out. So now how will we describe this triple integral r d of x y z? Okay. So one way would be that you just do it as you do it in the Cartesian coordinates. So how will you do that? So the 3 dz. So where z is varying from where to where?
X square plus y square less than 0 to, sir, 0 to x.
But here there is one thing. Should it be 0? Like, because this is infinite cylinder. So z, is it from minus infinity to x? There should be some restriction on this. I think I missed something probably. Okay, I think it should be some finite length. I think I missed something. So let's say it is, the cylinder is like this. Sorry, because otherwise you understand this is minus infinity to x, right? So I think we should consider on finite cylinder. So let me write this one. So maybe this is the cylinder that we have. Okay, just starting from 0 or whatever length you want. So let's say this is something. We'll see if that is needed or not. I don't know. Because anyway this is cutting here, so it's fine. So my cylinder, as you are saying, that it will start from 0 and it will cut till x, right? And now what will you do with the other thing? So you have to look at this projection, right? As you mentioned earlier. that we have to look at the projection. But how will this projection look if you just concentrate on this?
Circular, sir.
Will it be completely circular?
So there will be
Because
some
there is
things.
some cutting is also there, right?
Yes, sir. Yes, sir.
So see, this was
Triangular shaped, I think. Something triangular.
a little bit triangular. Just, that. Okay, so this is the circle that I have. Okay. So this is the base of cylinder that we have. Now it is coming. So you just imagine that above this, like I have a cylinder kept on it. Now when you cut it like this, right? So the it's like how should I say? So z is suppose like z is this straight line, right? So z equals to x means what does that mean? That it is coming at 45 degree. Yeah. So when you cut this off,
Sir,
you will be left out with this.
tilted circular region, I think.
Not tilted, like when you are cutting like this, right? So when you cut, it will pass through here. I mean, it's like the plane is like this, suppose. Then it will left out with this part.
Yes, sir.
You can consider like you have a carrot, okay, and then you are cutting it at 45 degree. So you can think that it would be like the lower part would be a circle.
Yes, sir.
Yeah. So it's like that. When you're cutting salad, also you put it diagonally, like sometimes, just to be fancy. So that the base is still a circle, right? Okay, I mean it should be semicircle. Like when you're cutting through the origin. If you consider center of the cucumber as origin, then you will left out with this semicircle. If you consider the edge as the origin, then you will left out with circle, right? So over here, this origin is in the between, right? So now here you can clearly see how will you write your x and y. Again, as before, you can write your x. So let me see how this figure will it be like this or this. It would be like this only. X and y. So it should be like this only, the after part. Okay, this one. Okay, let me swap this off. So now you can write again this as usual. So x is, let's say, varying from 0 to 1, and y, okay, so x is or should I write with y? Yeah, no, it's fine. X is varying from here. Yeah, it's I think let's write it with y. So y is varying from -1 to 1, correct? And at the same time x is varying from this 0 to root 1 minus y square, 0 to -1 to 1. This is one way, or if you want you can write it in polar coordinates as well, right? I mean this part. So or this is equal to, let's say, so z will leave it as it is, dz. So this was, what was this, dx dy, and here you can write r dr d theta, where r is varying from 0 to 1 and theta is varying from -pi to pi. Okay, so these are the same thing. So this is in polar, this is in Cartesian. Okay, so you can try to evaluate these integrals. Okay, is it clear?
Sir, I think calculation of double and triple integral needs profound knowledge of geometry, sir.
Over here you are saying this one?
No, sir, the region, sir.
Oh, to find the region.
Yes, sir.
Yeah, you have to imagine a bit. Like the more complex picture gets, like you have to deal with
I
it.
think not bit. It is more than bit, sir.
How? Like in this case, you are saying?
Yes, sir. In each case, sir, we see that we have to, sir, imagine the, sir.
No, in this case it's simpler, right?
Yes.
In this part. Okay, so here I am taking finite length cylinder, that I should mention. Finite length. You can take greater than 1, you just take, so that you escape this part. So maybe let's say of length 2. I mean 2. Okay, so from 0 to, you understand?
Sir, in two-dimensional cases, sir, it is easier, sir, I think.
Obviously it is easier if you compare, but
And
over
but
here
in the
it's
case of, yes, sir.
yeah, I can understand that that is there, that it's a bit complicated to even draw the picture. So
Yes, sir.
but like once you try to understand it, I think just you just have to give some time, that's all.
Yes, sir. Yes, sir.
Okay, so that ends today's session. Okay, so see you next week then.